All right. Happy Wednesday. Um, First order of business. I'm sure you're all very excited. We have a pretest here. As part of our accreditation process, we assess a bunch of things, the Common Course outcomes, the program outcomes, and we do these pretests here. Um, it's not hard. I'm going to put it in Canvas. Do it at some point in the next week, if you could please. There's just a couple questions here, just to kind of get a baseline for where you are in your C++ journey, given you've taken 150, 200. So kind of as you've progressed through the program, we test to see did everyone get to where they should be for the next level class, essentially here. So it's just three questions, a little 2D array question here, and it returns an integer with the total number of even elements in there. How do you loop through a 2D array, find the even numbers? It should be super easy, is the idea with this one here. This next one, you're writing a class here that has some values, right? And you make a constructor that has some values, or accepts some arguments, right? So you're fleshing out this class here. Again, nothing too interesting, but then also the destructor, which makes sure we free up some memory here. With some of that dynamic memory stuff we looked at, right, from 200, making sure we can do that one. And then the last one here is a template function, right? Bringing back all that template function funness here, making sure we're good with that. Uh, I'm not going to print it and make you do it on paper because that's dumb. We shouldn't do things on paper in computer classes. But just imagine you're doing it on paper here. Give it your best efforts. Type into it is perfectly fine here. But don't actually go out and write the code and copy paste the code. Is that a fair? So just give me the best you can, write in Word or whatever for it. It's just an assessment. It's a 1 point thing. You get the point if you turn it in. Okay, I'm not marking you right or wrong in these things. So as part of our assessment process, I'll go through and see if you got it right or wrong. And I say, oh, 75% of the class did really good on this one, but only 50% of the class did good on the template stuff. That sort of assessment here. So I'll drop that one in Canvas here, and I'll make a 1 point assignment for it. Nothing very exciting. Um, Nope, that's the wrong class. Oh my goodness. Friends, I'm still too tired here. There we go. This is the right class. That's why we had less files. Okay. Um, so we have, we'll call that a quiz. Why not? We'll do this as our pretest here. So sometime by next week, just for 1 point here. Neat. Upload, pretest. And you were doing on paper without a computer. Type into Word. And you can upload that one there. And this becomes a link to a file. File pretest. Okay. All right. Awesome. I think things went pretty well with Project Zero, but again, hardly called a project. This was just our example. Can we get GitHub working? I had a couple questions here and there. Great. If you ran into any issues, I could still help. I will be using GitHub for everything here on out because code shouldn't go in Canvas. Again, that's a hill I'm going to die on. So if this didn't go well, I need to help you get it fixed so it does go well in the future. Okay. And this was just our trial run. And you got some 1 point for doing it. Again, here we'll actually do a slightly more interesting project. We'll start today. Here it'll be worth more than 1 point as we go. So that's sort of the plan with that. All right. So we're a little short on time this week, but I think we'll be perfectly fine here. We're blitzing through variables, conditions, and functions. Variables are variables, not anything interesting here. We're going to look at how they work in Python. If you're coming from C++, Python is typeless, weakly typed, and that'll be a bit of a shock to you. It's okay. You'll get over it because Python's amazing. You don't have to tell Python, hey, this is an integer. If you assign an integer, Python knows it's an integer. Right? If you assign a string, Python knows it's a string. You don't have to tell it it's a string. Right? It figures it out. I don't know if anyone showed you the auto function in C++. Everything's auto, right, in Python. So works out pretty well. Conditionals are if statements here, and then functions will get to be a little bit interesting. We have a couple fun things we can do with functions. we'll get there. So let me fire up PyCharm here. Let's start a new project. We'll get through some examples, get to our first project. I'll have 2 weeks to work on that, so it'll be due 2 weeks from Wednesday. Should be fun. I won't see you Monday for MLK Day, so we're off again for MLK Day, and then we come back on the 21st for iterations and strings. Again, it goes pretty quick for loops, right? The Python does a couple fun things. The loops are a little bit different. A for loop isn't the same thing as a for loop in C++. We'll get there. And then we got lots of fun string shortcuts. Really nice, easy ways of working with strings we can get to. Yeah, apparently, I just don't like Mondays because we don't have class the following Monday either. Um, yeah, we'll get there. All right, so let me start up a new project here. Again, for my purposes, I'm going to put them all in a course repository. When you do your projects, you'll put them in the project repository. And then for the next project, you'll get a different project repository. And the next project, a different project repository. This way, you just have one class repository to go look at here. So um, I can go find it in my GitHub, 298. Uh, they sort this direction only, 298. And then I'm going to make a subfolder here so that it's slightly more organized. This is week 1, right? You don't need to make the subfolders because you already have a project 0 or a project 1 or a project 2. If you want to add a subfolder, go for it. It's not going to hurt anything to have more folders, right? But I like the welcome script. That way I don't have to make my own Python file. If you forget to check that box, it's okay. You can go make your own file here as soon as it loads. You just right click on your project, the folder here, and say, hey, you want a new Python file. Usually we call it main. That's just a convention. Doesn't have to be named main here. It's okay. Um, it's not like you have to have that main function for it to run. Python will run whatever file you tell it to run. It doesn't care what it's named, right? It actually executes the Python executable. It says, please run this Python file. When we print hello world here, it runs this one here. And we see, hey, Python executable, please run this main file here. So if you rename your file and we call it, I don't know, Wednesday, and we run Wednesday, it just runs the Wednesday Python file, right? The word main doesn't do anything there. It's just usually the file that runs will call main just by convention. It's just a nice common practice here. So we'll put it back to main. All right. So for variables, again, we use this weakly typed here because we're not telling it what type of variable we are. So we have some number, we can assign it the value of some number. Now, this is an integer, so Python knows it's an integer. If you're curious, you can actually ask Python the type of your variable here. It'll print out the type that it knows what it is here. So it knows it's an integer, right? So the type is a built-in function that tells you what the type of variable is, which is kind of fun. So you can have numbers, you can have floats here, floating point like 7.7, and we can print that type. Very exciting. And you guessed it, it's a float, right? So we have integers, we have floats. We don't deal with doubles. It's okay. That precision doesn't matter too much here. Again, I wouldn't do financial math with straight Python, right? Just the way numbers get rounded and multiplication happens with floating point numbers, it's messy. You don't want to end up with extra trillionths around here. Weird stuff happens. So just be a little bit careful. Same with your floating point numbers, your doubles. You have the precision, but it can get a little weird. Um, for strings, right? So some word, the string, again, you can use double quotes here. You can do other word. You can use the single apostrophes here. Both are perfectly fine in Python. Just make them match, right? Which is nice then. So if you have like a name like O'Neill with an apostrophe, right? You can have the single apostrophe inside of the double quoted string here. Or if you want here, you can have, a quote mark inside of a single quoted string and not have to deal with any of the objects escaping here. Or you can, of course, still use your backslash to escape your characters if you like. If you really miss doing that every time you wanted to put an apostrophe or quote in, you can still use your escaped characters here. So that one gets to be fun. And those are strings. So if we print the type of those, we'll get a string here, or a stir. It's a string, and I don't know why we saved 3 letters, but sure, we saved 3 letters. It's a string here. Okay. If we want to get input from the user, input always comes back as strings. So if we don't want it as a string, we have to do some sort of conversion here. So if we ask the user to enter their favorite number is going to be input, and then in the input parentheses, you can give it the prompt, whatever you want it to say. So enter your favorite number, and then we can print out your favorite number times 2. Let's multiply it by 2, right? So what's your favorite number? 7? So 7 times 2 is 77. Oh, wait. Uh-oh. Um, Strings, when multiplied, just get repeated that number of times here. So it's really fun like that. So you can multiply string, just gets repeated. So if you want it as an actual integer value, you have to convert, right? So to convert it here, we'll say this is my favorite number, then equal an int of my favorite number, right? Hey, Python, turn this thing into an integer, please, right? And then when we print out our favorite number times 2, now we get favorite number 7, we get 14. Now what's fun is the favorite number variable at one point was a string, and at another point is an integer. You can do fun stuff like that in Python. Python doesn't care. You can change the type of value being stored by the same variable. Some people might consider that bad form. I don't know. I've been doing Python so long, I don't particularly care. It doesn't offend me when the type of variable changes. To you, you might be shocked. It's okay. It's not the end of the world. Um, and we can actually see that again. So if we want to print the type of it, each time here, favorite number, and then we'll print the type of favorite number again here. So we'll see it change. It's very exciting. Goes from a string to an integer. So behind the scenes, what Python is storing is information about your variables. Right? So behind the scenes somewhere, Python knows that this type of variable is a string, and behind the scenes it knows now it's an integer. Right? And it knows where it's storing in memory, and all that stuff it has to manage to track our variables here, it does behind the scenes for us, which is really cool. Let me pull up Dr. Chuck's book here because I forgot. Make sure we don't skip over too much here. Chapter 1 was very interesting, right? All good stuff. Everybody read it? Or at least you skimmed through it, right? That was the point here. I wasn't going to give a quiz on chapter 1, but I'll probably remember to post a quiz for chapters 2, 3, and 4 before today, the end of today, so I won't forget. Yeah, it'll just be on Canvas. Yep. Um, Variables. There's a couple rules around your variables here. You can't use any of the reserved words. Go figure, for our variable names, because they have special meaning in Python here. You can use underscores in your variable names. That's pretty common. So our usual naming convention is this snake casing, where everything's lowercase with underscores here, rather than the camel casing, where every next word gets a capital letter. Most people tend to like this sort of formatting for Python. I don't know why. It stuck. I don't care how you name your variable names, right? If I can't read them, I'm going to make fun of you and tell you you have terrible variable names. But if you like camel casing, go for it. I don't care if you use camel casing or snake casing. It's not really a big deal here. Um, our operators and operands all work the same way here. The double star is our shortcut for exponential exponents to the power of. I'm terrible at math here. So 2 to the 3, right? Right. 2 to the third power, right? 2 to the third, or this one, right? You can't use the caret here. That's just our shortcut for that. You can also use the math library if you're so inclined, but we've got that shortcut here for the operator. Doing your division, your decimal places here. We're using Python 3. Python 2 has been out the door for quite some time now, like at least a decade, but some people still use it, apparently. I don't know. I have not seen it myself, but I've not seen everything. And then if you want integer division, you can do the double slash here for integer division. Right? So if you like when you divide two numbers to lose the decimal place, go for it. Use your integer division. And then our expressions, order of operations still works the same way. You're all pretty good at this stuff here. Um, I think it's just clickbait now when people post those. No one can solve these math problems. I don't know how some people got through life and don't understand order of operations, but that's okay. And then modulus, it still gives you the remainder, integer remainder of your division. Here, that one's the same. For strings, like we saw, you can multiply, you can add two strings together. So the right, so I don't know, name, then some word plus other word. Now, when you add two strings together, you concatenate them, you don't get spaces, right? So they all run together here. So if you want spaces, you just add in a space, right? Add in your own space. That's perfectly fine here. You can concatenate those. We get our inputs from our users. We can convert here. Comments. I don't know if I've told you the story about comments. Did I? Sometimes I repeat the same story twice. So if I'm saying the same story I've already told you, just holler at me and I'll stop. It's not worth your time to hear it a second time. Um, but back when I was in school here, this was many years ago because I'm an old person now. I don't think I'm that old, but it's been quite some time. Um, my first intro to programming class, we had an assignment here, and I did everything we needed it to do here, and I got my score back, and I didn't have 100%. And I was one of those kids who like really wanted 100% on everything here, and I was really salty. And it's like, why didn't I get 100%? I did everything I'm supposed to do, and I got a point off because I didn't have a comment where the instructor wanted a comment to be to tell him what my code was doing. And at that point in time, young Eric Chinesky said to himself, if I ever get a chance to teach, I will not give points for comments because that's stupid. Code does what it's supposed to do here. I should get points because it does what it's supposed to do. And I've stuck to that ever since. So I will never ask you for comments. I will be like the compiler or interpreter and just ignore them. If you'd like to put them in, have fun. Go nuts. I don't care. I won't read them. I'll just ignore them. Okay? So I don't need them. It's not worth time. If you can learn how to code, I figure you can learn how to add comments if you need to add comments for some sort of documentation. There's some really good purposes. There's a really cool library called PyDoc that will auto-generate documentation for your libraries if you're going to write code that other people will use long term. If you're going to write a very popular common library for people, please document it, make it be nice and friendly. For our purposes, you're not going to do anything that cool. It's just not going to happen. Okay, so we don't need to document it. It's okay. Um, and I've ascribed mostly to the little, I guess it's rainbows and unicorns sort of fantasy land that code is self-documenting, that you can see the variable names and you can read the code and understand what it's supposed to do. Most of the time, that's perfectly fine, right? I don't need you to comment saying, hey, you're concatenating two strings together. Don't tell me what the code's doing. We can read that. If we need to add why we're doing some sort of interesting, weird, funny thing here, context might be helpful in a comment. That might be useful here. But I don't need you to tell me what you're doing. Anyway, all right, so I despise comments. I think they're stupid. Um, Not everyone here shares that opinion. So it's okay. If someone asks you for comments, smile and nod. You can put comments in, but I won't. Variable names, great. Yeah. All right, cool. So that chapter goes pretty quick here. I don't think we missed anything. For conditionals, our ifs, elses, Boolean expressions here, right? Relational operators, greater than, less than's, not equals, equals. We have an is operator, which is fun in Python. So it's checking, is it actually the same location in memory here? Gets to be kind of interesting. So if we have, I don't know, some value 10 and other value is 10, and we print some value is other value, we get true. It seems a little weird here, but the way values are stored here, when it's getting interpreted and run here, a little bit of magic happens here, and it knows it can save the same value here. But if we ask for an int of an input here, of enter 10, and I enter value 10, we get still true. Still a little funny here. But start this one at 5, other value is 10, take some value plus 5, right? You can do your combined assignment operators here. 5, 10, still getting true. A little weird here how it thinks it's the same value here. It's okay. Most of the time, we're not going to use the is operator. This is not super helpful for comparing integers, right? Usually we would just use equals. Right? Does it equal another one here? The is operator is much more helpful when it comes to objects, and we're dealing with, is it the same object that I'm storing somewhere in memory? That gets to be much more useful here. So you might see it occasionally here, but it's not helpful when you deal with integers. It's not going to do everything that we want it to do every single time. right, for integers here. So usually we'll just leave it as equals for these ones here when we're dealing with these primitive types here. But I can have like so some list. We didn't get to lists yet. That's okay. This is assume it's like a vector here. You can add a bunch of things here, and another list then is 1, 2, and 3. And now with this one, we can compare. You can say, is they the same? Is they? I'm terrible in English too. Let me print this one off. 7 and 10. Now we get a false. They are not the same list here because now we're dealing with objects here. These aren't the same ones in memory, right? They have the same contents here, but they're not the same in memory. Um, it's a little bit funky with the integers. Don't worry too much about that. But if I want, I can say some list equals another list, right? Assign the value of another list to some list here. And now they will be equal here because they are the same value in memory. 7 and 10. Now they become the same here because I've pointed two variables at the same location in memory. I said this one equals this one here. We've copied it. It's not even a copy, right? We have two variables pointed to the same place. Um, so it gets a little bit funky when we deal with our objects. With is for logical operators, we just get to use English words. We can say and or and not. We don't have to use ampersands or pipes or exclamation marks. Right? We can use English words, which makes a whole lot of sense here, right? Because we're the ones writing the code here, so we get to read it here. Um, Now, Python is a little bit funky here compared to some other languages because it is truthy. So by truthy it means everything is true or false. Like literally anything you have is going to be true or false here. So I can say, hey, if some value print, it's not 0. Okay. So some value we said was what, 10 up above here, right? 5 plus 5, it should be 10. So we run that one. Some value is not 0. So for numeric numbers, anything other than 0 is true. I don't know why, but that's how it works in Python. So 0 is going to be false. Anything else is true when it comes to a numeric value. So for strings here, some string, if it's blank here, you can say if some string print as text. And then otherwise, right, our else. So if now we use a colon here because we don't have curly braces. Python's not a curly brace kind of language here. It uses colons and then it uses white space, which is super weird for a little while. You'll get used to it eventually here. But everything indented underneath the colon belongs to that code block. So instead of having a curly brace here and an ending curly brace here to define where the code block starts and ends, you just use white space. You indent. So you'll see stuff is indented in these blocks here. And as much as you want to put here, right, as many lines as you want here, just pretend like you have curly braces there. If you really want them, it's okay. You can pretend they're there if it makes you feel better. You can add a comment curly brace and, that way you don't miss them too much here. It's okay. And it's empty. So with strings, if it has some text, it's true, right? If it's blank, it doesn't, right? Because this was blank string. It was empty. But if I put a space in here, 10, 10, a space is not empty, right? It's not an empty string here, right? So it has some sort of text, right? It has some characters. The space is a character, right? Whatever the ASCII code is for it, I forget, a Unicode code is for it here. That's a character, right? So it has something there, right? Um, Conditionals, those are good. Ifs and elses, great. Fine folks at Python decided typing the word else is too much if you want an else if, so you get elif. Else if, but take out 2 letters here. Congratulations, you've saved two characters of typing. Um, so we'll go for it. So we'll say if I'll have score as an int of an input, your score. I'm going to tell you like 0 to 100. Usually your prompts should tell the person what they should be entering here. Right? That's just a helpful, if you're asking them to enter something, give them a hint what you want it to look like. Here, you say, hey, my score is greater than a 90, or what, greater than 93, right? And we're going to print an A. Elif, my score is now greater than or equal to 90, right? We can print an A minus. And if my score is greater than or equal to, what is it, 87, or print a B plus, and on and on and on, right? You would just chain these together, if, elif, and eventually you can have your ending else if you want here. Um, but it's nice, right? And the same sort of condition, top bottom works. They'll be mutually exclusive, so one and only one of them will run. I don't need to also have in here that the score is less than 90 because you can't get to here unless your score is less than 90, right? Because it's going to go in order of our executions here. Save yourself some time. The other fun thing you can do, if you want, is you can sandwich your values here. So you could put 90 greater than score greater than or equal to 87 here, right? So you can sandwich them, and you don't need to say this one less than this one and this one greater than this one, right? You don't have to use the anding here. You can just sandwich them in. But again, that's redundant because you can't get here unless you're less than 90 here. But we'll just can sandwich values between relational operators. Sandwich. I can't spell it all here. Um, is that helpful? So leave a little note here. I'll try and leave notes occasionally, as much as I hate comments. Sometimes it's helpful here because I just ramble and write weird stuff here. So it's adding context. So we got those ones. If, elifs, great. We got our relationals nested, so you can put ifs inside of ifs. Again, nothing new with that one for you there. Do you guys ever draw your flowcharts? I don't know if we still draw these anymore. We did like some UL activity diagrams, or you might have seen these at one point here. Sure, it's fun. Some people like their flowcharts. Um, Now we get right into exceptions, which is fantastic here. So how we handle our code crashing here. So when I try and convert something to a number here, enter your favorite number. If I say 10 here, it's going to crash on me, right? A value error, invalid literal for int with base 10, quote 10. Right? That's not an integer value here. It's a string, right? So that crashes. So if you want to avoid crashing and handling exceptions, we can use a try block, and then in Python, we use except. So it's not try catch, it's try except. It works the exact same way here. So if you want to not crash here when we convert, let's see. So we will try to convert to an integer, your favorite number. And if we get some sort of exception, oh goodness, what is it? Except, oh man, okay, I've got to look at this here. I forget. I'm so bad at this already. Yeah, just an accept. Why is it cranky? Too broad. Oh, it doesn't like that it's too broad. I'm just catching every possible exception here. That's okay. That's not a numeric value. Um, so if you want to get the specific types here, so we would catch a value error. Specifically, if you want to catch just one type here, and then you can get the actual exception itself if you want here. You can get the message off here so you could print that exception if you so cared. Or you could print your own error message here. Either one's going to be okay. So that as is optional. So we go. So now if I enter 10 here, we don't crash. We get, here's the message from the exception, right? That's when we printed out the exception. And then we get our own print here. And then, of course, 10 times 2 is 1010, right? Because why not? So try and accepts are fantastic here. Our logical operators, they do short circuit, same way as in C++, right? So if you're anding a bunch of things together, the first time it sees a false, it just stops because it doesn't need to continue on, right? If you're ORing a bunch of things together, the first time it sees a true, it just stops because it knows the whole thing will be true here. So we can do the same sort of short circuiting, which is helpful. Um, and then our error messages here, you get all sorts of fun error messages here. If you don't have stuff tabbed in correctly here, it's going to yell at you. Indentation errors for things like that here. We saw a couple other errors, like if you're missing your parentheses or things like that, it will tell you, hey, you've got problems at specific line numbers. That's sort of common thing here. If you pick wrong variable names, right, same idea here. But now it's going to run weirdly with this error here. So it's after 10. Now you get a name error here. And look at that. It's even suggesting, hey, did you mean this one? It's kind of cool. It's like, hey, it's pretty close to a different one here because you typo things all the time. Now, most of the time, you shouldn't typo your variable names here because you shouldn't be typing your variable names, right? If you want some value, type a couple letters and just hit tab, let it type for you. right? You're much less likely to make typos if you let it type for you here than if you try and do it yourself, right? So use the tools, use your shortcuts. Hopefully you don't have like 6 different things named sum like I do, or 5 different things named sum. But again, just let it type for you here, and use good variable names, right? It's okay if it's a long variable name because you only have to type it one time. Every other time you use the variable name, you shouldn't be typing the whole thing, right? Be efficiently lazy. Let the tool type for you there. So that's our conditional expressions here. One other piece I want to show you here that nobody ever uses, and I know you give me chatbot code if I see these, is the ternary expressions. You might have seen them in C++ as well. You can do them in Python. Nobody uses them when they're first learning how to code because they're obnoxious and confusing, right? That's a pretty big hint for me. So if we're going to say, hey, um, why don't we do, we'll say, we'll ask the user how much money they have, and then we'll decide what they're going to have for lunch here. So we'll have a money is an int of an input here. How much money you have for lunch? And we can say if my money is greater than 10, then we can say lunch is Picasso. Picasso, what do you get at Picasso? The deli sandwich or something, or just the wrap? Picasso wrap? Sure, we a wrap. If it's not more than 10, lunch is ramen noodles, right? So we've got one check here if something's true or false, and we're going to assign a different value here when we're done. Now, what's fun is Python knows lunch will have a value by the time we end here, so it's not yelling at me that we didn't create lunch first and then we've only assigned it inside of blocks because it realizes one of these two will run here, right? So we should be able to figure out here, 10 ones are a bunch of tens here, score the 100, right? We got an A. All right, so if you have $11 for lunch, we get a Picasso wrap, right? Otherwise, we'd get our ramen noodles here. So this is the slow, terrible way. Look, we wrote 5 lines of code, 4 lines of code to do this here. We should be sad about ourselves because we can do it more efficiently, but also more confusingly. So we can say lunch equals here. Well, lunch equals what? Well, lunch will equal a Picasso wrap if my money is greater than 10, else ramen noodles. That's our ternary expression. I don't know why people would use these. I hate these. Yeah, it's kind of hard to read, and code should be for people, and people should be able to read it. Now, if you've been using Python for long enough, eventually you're like, oh, okay, I know what's happening here. I know it's weirdly backwards, and you're okay with it. Okay. You guys probably are not going to get to that point, and that's okay. That's fine. Eventually you'll do enough Python, and be like, oh yeah, this is perfectly fine. I get it here, right? Print our lunch again here. So we comment this one out. We do it this way. 10, 10, 10, and 10, and we get ramen noodles, right? Because this wasn't true, so of course you didn't get the thing on the left of it. Why? Like, why wouldn't it come after the if? I don't know. The whole syntax of this is really confusing, but we get it over here, right? Very exciting. Um, this is the reason I found out a bunch of people cheated on the one exam because they all had ternary expressions. I was like, that's really sus. So I can say that, right? That's a cool word. Cool people say that. No? Oh dear. Okay. All right. I just sound old then. All right. So that's our conditionals here. All right. And we'll get to functions here. All right. Hey, look, type is a function. It's a function built into Python. So Python has a bunch of built-in functions like print. Print is a function, right? Int is a function. Input is a function. Right, you got the picture. We know functions. Very exciting. So if you want to make your own function, you define them. And instead of typing define, you type def for define. It's short for define. But we're going to define a function here. So this is our function. And then a set of parentheses, right? And then a colon. So anything that is indented under this belongs to this function and will run when we call this function here. So we'll print there, print another line, and print, and done. So our function will just print something here, right? We don't need to tell Python. It doesn't return anything. We don't need to give any void keywords here. we just stop when we're done here. Right? When it gets to the end here, we're done. So if we call our function here, it does our function. I guess we should do this at the top here. Might be a little weird, but that way we don't have to run through everything here. Kind of go top down. We get, hello there, another line done. Cool. Now I don't even need to say print our function, right? Because if we print what we get back from this, we get none. So none is a null. It's the null pointer. It's the nothing keyword here in Python. We didn't return anything, so there's a implicit return none at the end of functions if you don't return something here. This is implied. So functions without a return will implicitly return none. Implicitly, there we go. I love how it spell checks me right in PyCharm as the nicest feature here. Okay, so we don't need to print the output of that, right? Not very exciting. Now, the other fun thing you can do, though, is you can print our function without the parentheses here, and you can get a little bit of information here, because this function is actually now an object in Python. Functions are objects. Right? It is the name of our function, and I think this is the memory address. I don't actually know, but I feel like it's probably the memory address. That's going to be my best bet here. So if you're not careful with your parentheses here, you can get some weird stuff happening. Right? That's all. So we can make our own functions. So this one doesn't have any arguments, right? No parameters, and it doesn't return anything. We can make functions that do return stuff. So we can have a, I don't know, let's double. So given some number, well, let's double the number. So we're going to return number times 2. Right? Very interesting function. We'll just double it here. Right? So this one doesn't print anything, right? We're just returning a value. And we're going to give back something here. So I could print then double of 10. Right? We should get 10 times 2. We can also print double of 10 and get 10 times 2. Right? 20 and 10, 10. Python doesn't care what type you give it. And that's one of the weird things here. Because it's weakly typed here, you just say, give me a number. Hopefully they give you something that's numeric here and you're not going to crash. But if they give you a string, sure, we can multiply strings too. Why not? It might work here. Now in Python 3, it's becoming more common. Still not all Python code you'll see. You can give type hints. You can say, it should be this type here. So to give a type hint, you give a colon and say int. So this is the hint, type hint is colon and the type. Or colon type, I don't know, is type hint. I don't know how to, is that helpful? How to describe that? Colon and then the type that you're expecting. So now it warns me, it's saying, hey, expected type int got a string instead. Still lets you run though, right? Python will let you do some weird stuff here. It's like you probably should give it an integer. It wants an integer. It might break. We didn't break, so we got lucky. But so if you want to add the type hints, you can do that. It's kind of helpful. And then you get your own sort of error checking to make sure you didn't screw something up yourself, giving it the wrong type here. But you don't need them. They're optional here. You should say that's optional, right? Again, depending on whose Python code you're reading, you'll see these. You might not. Depends on what they're doing here. Excuse me. And then you can even give hints. Can you give hints for return types? Python return type. I think you can. Yeah, okay, that's right. That's the arrow notation. Where is it? After or before? It's before. Okay, so if you want to give a hint for the return type here, you use an arrow like this. I don't know why here. So this is the optional return type hint, is the arrow and expected type here. So it's going to look pretty crazy here versus the initial version without any of the hints, but it makes it a little bit nicer, right? Because now I know what I'm expecting to get back. I know what I'm expecting to give here. But they're optional. If you'd like to use them, great. If you don't want to use them, that's fine. It's not going to hurt anything here. All right, cool. So that's some of our basic functions. Built-ins, we've got mins and maxes built in. So if you give it some sort of list or collection, it'll tell you the largest and the smallest, which is really nice. The length of a string here, or any sort of collection. We haven't got to the other collections yet, but it'll give you the length of them here. Conversions, we did ints. You can do floats as well. You can turn numeric values into strings, right, with a string, right? The math library has all sorts of cool math stuff. So if you want to import math, you can go through and do cool things with math, like the sine, given some radians here, sure. Random numbers is much more fun here. So we're going to import random and get some random numbers here. Math library is not very fun. But if we import random, now we can get some random values here. All right, so we'll have a random number is random.randint for random integer. Now, randint wants an A and a B here. This one drives me absolutely bonkers here for randint because it is inclusive of both ends. So in PyCharm, you can hover over and it'll give you this documentation hints. This is why if you're writing a library, it's nice to add some comments for documentation. And we're not writing libraries. And it says return random integer in range A to B, including both endpoints. Python, as far as I know, is the only one that does it weirdly like this here. So you're inclusive of this end rather than exclusive here. And I always forget here, and I complain about it. So we'll get a random number 1 to 10 here. And then we'll ask the user to guess a number. So we'll say a guess is an input of guess a number 1 to 10, right? And then if my guess is equal to the random number, right, you win, you can go home. Otherwise, print, you have to stay. All right, should we give it a try? Guess a number, 1 to 10. 4. You have to stay. All right, let's try it again. Who else wants to guess? 1? You have to stay. All right, try it again. Who else? 9? You have to stay. Oh, try it again. 7, I heard? You have to stay. Try it again. 3? You have to stay. Oh, try it again. 2? You have to stay. Try it again. 5? You have to stay. You said you wanted to cheat? Okay, good idea. Let's put a breakpoint in. Run in the debug mode. The random number is 7. So step over. Hang on, step. There we go. Guess a number. 7? Step. You have to stay. Oh. I'm really confused now.
It's a string. It's a guess, it's a string. That's fine.
Yes, it's a string. Strings will not equal integers. You guys have to stay. So the person who caught that, you get to go. You're free to go. Congratulations. So be a little careful here, right? Int of an input here. Now this will probably work a little bit better for us. Yay. Should we try it again? Oh, debug mode, right? All right, random number is 3. Guess a number. 3? Step. And you win. You can go home. Yay. All right, so be careful with your inputs. Make sure we convert here, but random numbers are much more fun here. And you notice I didn't have to seed it manually here, right? I didn't have to do anything special here. It uses the system clock time seed automatically here. If you want to give it a specific seed, so you get the exact same pseudo-random sequence, you can seed it, right? So if you'd like it to be the same one, we can random.seed 10, right? I guess we do that first every time, right? Give it some sort of value here, right? Oops, let me debug mode here again then, right? Step, right? Now it became 10, right? And when I run again here, step over, it's 10. And if I run it again, it'll be 10, run it again, it'll be 10, right? Because we'll get that same pseudo-random sequence here. I'm going to leave that commented out. We don't want to seed it. Most of the time, that's not very helpful for us here. Excuse me. All right. Other fun things we can do with functions. So random numbers, great. When we make our own functions here, we can accept variables, definitions, usage, parameters. There we go. Fruitful functions. I don't know, Dr. Chuck calls them that. They return something um, versus ones that don't return something. You get the none. Excuse me. I love the reasons for making functions here. Again, we don't need functions. We could do the code ourselves, right? With not using functions, but you get some reusability, which everyone likes to focus on for being the main reason to use functions. But I think the main reason to use functions is you give yourself a name to what the code's doing, right? And you can break things down into smaller bits and smaller bits and smaller bits. You can solve hard problems in small pieces. Right? Works out really nice with that here. So if we wanted to do something silly like play rock paper scissors, right? We can break it down function by function by function into smaller bits to make it easier to solve. Now, again, at this point, you can do rock paper scissors. I'm not pretending like that's a hard problem here, but it's a quick little easy one for us to illustrate here. So we can say, hey, I don't know, the user's throw is a get user throw. User throw. I can't type. Oh my goodness here. And then the computer throw is a get computer throw, right? And then I don't know, display winner, given the user throw and the computer throw, right? That's rock, paper, scissors because we broke it down into smaller steps here, right? The harder bits of getting the user's choice here, we can leave for later. We can put in its own function. For getting the computer's random throw, we can put in a function, right? To figure out how do we win, lose, or draw, we can put in a function, right? We can break it down into smaller pieces here. You can do your functional decomposition, which is one of my favorite technical terms of all time here. And throw that out at the next time you're at a family gathering. Watch everyone look at you with funny eyes. They probably all know you're nerds, right? Because you're taking computer classes, but sometimes you can get funny looks still. And man, all that functional decomposition. I was so tired last night, staying up till 3 in the morning doing functional decomposition. No, it just doesn't hit. That's all right. So we can make our functions, right? Break things down little bit by little bit by little bit. So we can define our get user throw. Oops. Oh goodness. This one here, get user throw. I'm typing too fast here. Sorry. So we probably need to have them pick something here. And do we want it to be like a 1, 2, 3? Do we want it to be an R or a P and S? Do we want it to be the full word rock, the full word paper, the full word scissors? Right? Any way we want to come up with it, that's our choice. Right? I don't know. Do RPS or 1, 2, 3? Rock, paper, scissors?
RCS.
RPS? All right. So we'll have I don't know, the choice then is equal to an input. And this will be text then, right? We don't need to deal with numeric values here. We'll say enter I don't know, R for rock, or R for rock, P for paper, S for scissors. Now, it'd be nice to validate it here. We haven't really got to that point yet where we can validate because we haven't done enough of the Python code here. Should we do it anyway and just pretend like it's fun magic here? Okay, so we'll say while choice is not in R, P, and S. We'll get back to all this later. Don't worry here. We'll just keep on going. So I'm actually going to cheat here a little bit. We'll say choice equals something. That's not one of those things. And then it'll keep on entering here, right? And then I might want this in uppercase format here, right? They might have entered lowercase here, so I can say, hey, let's uppercase it. And we'll come back to all this when we get to strings next week here, but just for fun, right? We can uppercase it. If it's not in this list, this collection, it's actually a tuple here. It just keeps on going. It's a while loop. And eventually we're done here. We can return choice. Okay, nice and easy. Then for the computer throw, right? We'll define a get computer throw. We can just randomly pick 1, 2, or 3, right? We can do a random number generator, or we can do random dot, I think it's choice here of rock, paper, scissors. Python has some fun little built-in shortcuts for us here. We'll take advantage of those as much as we can. Random choice will choose a random element from a non-empty sequence. It'll pick one for us randomly, right? I don't need to reinvent the wheel here. Python can pick it for me. Right? It's nice. And then display winner. Find display winner. Actually, let's just right click here. Where's my little option here? Here we go. Create function display winner. Look at that. It's going to make the function for me. I like putting them up top. Doesn't matter too much here with some arguments. So if they're the same, it's a tie. right? That's the easy one. So if user throw is equal to computer throw, we just print tie, right? That was easy. Otherwise, ellipse, now my user throw is equal to rock, and my computer throw is equal to, so do you want to do wins or losses? Wins? Okay, so if they're a rock and the computer is scissors, then that's a win, right? Or if the user throw is equal to scissors and, or we should do paper next, right? And the computer throw is equal to rock, right? Or the user throw is equal to scissors and the computer throw is equal to paper. P for paper. Now it's upset with me because Python uses white space to hang things. You can't just enter down lines. It's upset that I just ended this line. So what you can do is you can add a backslash here. I didn't come up with it, but you can add backslashes to say, hey, the next thing really should be on the same line. I just don't want to go over too far here, right? And then we're going to print you win. We'll just say win. And if you didn't tie, you didn't win, obviously, then you lose, right? Keep it nice and easy and simple. You okay so far? Now we've done a bad thing here, is that I've got strings multiple times here, right, that are just hanging out as strings, and it's possible I typo them, right? That's considered bad form, right? So what we can do instead is we can have some essentially constant values. They won't actually be constant, but we'll pretend like they're constant values here. So we can say, hey, I want rock equals R, and paper equals S, and scissors equals, oh, nope, that's a P here. That one's an S, right? So I can make variables in all uppercase is your convention for constant values here. Nothing keeps you from changing them, but it's just our convention here. And then we can make a list then with rock, paper, and scissors every time and make this a little bit cleaner here and use our variables. And we'll do the same one here, rock, paper, scissors here. And then we can use our variables here as well. So we can say rock and scissors and paper and rock and scissors and paper. Now our code's much prettier and cleaner because we're using our essentially constants here instead of a bunch of literals that it's possible we typoed here, right? Much less likely to make mistakes if you use your constants here. All right, should we try it? Rock, paper, scissors, what should we try?
Rock.
Rock. Tie. All right, try again.
Rock.
Rock. You win. All right, awesome, we did it. So that was some functions. Now, a couple other things we didn't get to in here, but that's okay. Um, when we write functions, you can also have default values. Right? I think we got into that in C++. You could say, if you don't give me a value for this argument, we'll assume it's something. Does that ring any bells? So we can define a, what's the usual one here? Print date here, given a month and a day and a year, we'll probably assume is 2026 if you don't tell me otherwise, right? So you can say, here's a default value for that argument if you don't provide it, right? And then we can print out whatever format you want here. Now, the American syntax makes no sense at all because you start with the middle size, then go to the small size, and go to the big size here. So it's a terrible format. So we should do year dash month dash day. It's the ISO format is the better one. This actually sorts nicely as a string as well, going this format here. Or you can be European and do day, month, year. Go from small to big, but either way is fine. So if we want the year, the month, and the day, I'm going to stick all those together here. One other fun thing, again, we'll get to this when we get to strings next week here, but I want to show you for fun, is you can do a formatted string, and you can use string interpolation, which means I can stick variables right inside of my strings here with curly braces. It saves me all sorts of time here because I don't have to write it as print year plus a dash plus a month plus a dash plus a day, right? This string interpolation will substitute in variables in place where you ask for them, which is really nice here. Again, we'll get to that more when we get to strings, but this is the fun little format here. Then you can have the optional parameters if you want those as well for our functions. I think that covers everything you need to for functions. You okay so far? All right, fantastic. Let's talk about our first project. Let me go to make a new repository. It's 298, winter 2026. Call it project one. Again, I don't use any of the due date stuff in the Google or GitHub Classroom. We'll do all that at Canvas. Python templates. I think I got it. Private repository. And hopefully this works pretty well for us. Come on. There we go. All right. So this will be project one, due in 2 weeks from today, before class starts, because I'll go over the solution in class. 11 a.m. No, I really have to use the drop down? That's annoying. I'll say this is probably about 10 points here. All right. Please own the repository, create your project in the repository folder, and commit and push your code to GitHub. Submit the URL of the repository, add a screenshot of it running, showing each rubric item is working to the README, and include a self-assessment score. So the idea here, I'll give you a rubric, say you get 2 points for this, 2 points for this, 2 points for this, 2 points for this. You'll give me a screenshot for each one of those saying, here's where it does that. And then at the end, I got all my 10 points. Okay. If you only halfway got it done, give me a screenshot and be like, oh, I only got 1 out of 2 points for this one here because it doesn't really work. That's okay. It's up to you. If you didn't do it at all, be like, oh, I didn't get this one done. I got 8 out of 10 points. Yeah.
You want to screenshot of each one?
Yeah. Yeah. I mean, so one, depending on what it is here, you might be able to use like one screenshot to show 3 different things, but illustrate that you've completed it, right, for whatever it is here. Um, and the self-assessment score. Excuse me. So I'll post the rubric in a second here. We're going to create a very basic parable version of a tax income or income tax estimator. Okay, don't use this for real life. Real life income taxes are much more complex. We're just going to do a basic version here because I find it entertaining, and I have yet to find someone who understands how our progressive tax system works after doing this for many, 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 many years here. And I think that's on purpose, the way that taxes don't happen, but it's okay. I'll take off my tinfoil hat. We can get onto this stuff. So what we're going to ask for, ask the user in a loop to enter deductions till they are done. Again, we'll get to loops next week if you want. It's a while loop. They're not hard. This part won't slow you down. If you don't want to get to that till next week, just ask them to enter once, and then next week you can come and finish it, adding the loop here. It's not due for 2 weeks. We got a little bit of time, but it'll be in a loop. And enter deductions until they're done here, and then if the total deductions entered is less than the standard deduction, give them the standard deduction. I can't spell it all. My goodness. Standard deductions. There we go. The 2025 standard deduction. Really? We don't get like an easy hit on that? Okay, sure. Why not? I just wanted something easy. Where's the deduction? My good. Okay, here we go. 15,750 is the standard deduction for single filings. If you want to use the married filings, you can. It's okay. The numbers will all change, but single is probably easier for now. So if you can claim more than $15,750 in deductions, you can claim more than that. You'll pay less taxes. Other than that, everybody gets the standard deduction here, part of it being a progressive tax system. Okay. So then we'll do the same sort of thing here. Ask the user in a loop to enter gross income till they are done. So when you get your W-2 at the end of the year, you get a total income from this place. If you work at more than one job because you have to eat and pay rent and do all these sorts of things, you might have more than one W-2, right? So here's this gross income, here's the next gross income, here's the next gross income, here's the next gross income, whatever it happens to be. We'll pretend like 1099s from places like DoorDash don't exist. We'll pretend like you get treated like real employees or whatever. Again, the real taxes are a little bit more complex. This is just our simple version here. So that's your gross income. And then we'll calculate the adjusted gross income, which is gross income minus total deductions. So that's essentially what you pay taxes on. Again, essentially, don't get too deep into it here. All right. So you're going to pay taxes on your adjusted gross income. Right? And then for each tax bracket, calculate the taxes owed, and display. Now, the way our tax brackets system works, the Money Chimp site is better for this here, tax brackets. I like this one. It's a progressive tax system. So as you earn more money, you pay more taxes on it here. So everybody, no matter who you are and how much money you make, pays the same 10% on the first $11,925 of income, adjusted gross income, right? So still 10 cents on the dollar, whether or not you make $10 or you made $10 million, you still pay 10% of that first amount of money. Okay. Then for every dollar between 11,925 and 48,475, you pay 12%, right? For those dollars that you've earned. Even if you make 10 million, you're still paying the same 12% of this bracket here, right? Then above that, it goes up to 22, above that 24, 32, 35, and 37 for every dollar above this. So if you have an adjusted gross income of $630,000, you're not paying 37% taxes on your income. You're paying 37% taxes on $3,000 of your income. And then 35% of this chunk, 32% of this chunk. This is why your effective tax rate is never the top bracket that you're in. So just because you ended in this tax bracket doesn't mean you paid 37% of your income, right? You can make $10 million. You didn't pay 37% of 10 million. You paid 37% of, 9.3 million, which is probably getting pretty close here, but again, not exactly 37%, right? Because the money is taxed at the bracket in which it's earned. Okay. So when we're displaying how much you owe at each tax bracket, we'll say, hey, this is how much you paid at the 10% bracket. This is how much you paid at the 12% bracket. This is how much you paid at the 22% bracket. This is how much you paid at the 24% bracket. For a lot of numbers we enter, those are going to be zeros. That's okay. And then when we live in our fantasy world, we're like, hey, I made $10 million this year because we just want to pretend that we're rich here. Then we'll see how much we had to pay in taxes here at all the brackets, right? So to figure it out here, again, for that like middle bracket here, again, this is using the older 2012 numbers. They haven't updated their website in quite a while here, but that's okay. You take the top of the bracket minus the start of the bracket because you already paid your 10% taxes on this money. You're not paying 12% taxes on this money again. You'd be real mad at that point here. So it's 48,000 minus 11,000 here that you pay 12% of, right? So as you earn more money, you pay more taxes at that level here, okay? So we're going to calculate that for it here. So taxable income, we can say, hey, whatever it happens to be here, we'll see here's the total taxes paid, your taxes as a percentage of income here, and then your tax bracket, the top level bracket you landed in with a $100,000 income, you only paid 16.9%, even though you ended up in the 22% bracket, right? Is that even, shouldn't have ended at 20. Oh, yeah. So we didn't get above the 22. So we paid a lot of taxes at the 22% here. Yeah.
Oh, sorry. Can you just copy and paste that into the?
Yeah, this link.
Yeah.
Yep, good idea. So uh, sure, put it up here maybe. Okay. So 10% bracket, $10 or something here, 12% bracket, 200. What I'm just, these are nonsense numbers here, right? Whatever happens to be here, 22% bracket, $0, right? And it's okay if most of them are zeros. That's okay here as we go. Um, so that's standard deduction. Is that one even listed here? I forget if it was listed here or not. 25 standard deduction. We looked it up and I forgot it already here. 15,750. 15,750. Okay, so there are things that are deductible because of our tax policy and the lobbyists who lobby Congress to give you tax deductions on things that are bizarre. So if you want to look up things that are deductible, it's okay. Charitable deductions to 501c3 nonprofits are tax deductible if you keep your receipts and those sorts of things. And we like that one because the idea is charities can provide services for people. So we incentivize people to donate to charities by not charging them taxes on money that they donate here. But you have to give a significant chunk of it here. But things like the mortgage interest. So if you buy a very expensive house here and the mortgage that you have on that house cost you X amount of money here, the interest portion of that is deductible because the government wants to incentivize homeownership. But then the people who get the most benefit from it are the people who buy the ridiculously expensive houses. Go figure, right? The people who really need that tax break, obviously. I don't know. It's a fun system. So all sorts of interesting things are deductible here. Again, don't worry too much about it. Just let them enter whatever numbers they want here. If they commit tax fraud, it's on them, right? We're just giving them an estimator here. And we'll go from there. And then at the end here, at the end, oh goodness, at the end, can't type. Display total taxes owed, total taxes as percentage of gross income, and total taxes as percentage of adjusted gross income. Right? So the last couple of little details here, right? How much is it total? So at the end of the year, if we just had to write a check instead of it coming out of our paycheck every time we get a paycheck here, what would that look like? And people would be a lot more upset about their taxes, obviously, if you had to write a big check at the end of the year. And then what is that a percentage of your gross income? And what is that a percentage of your adjusted gross income? Um, Now, for our purposes, you can't have negative taxes, right? So if your standard deduction is higher than your income, we're just going to say you pay no taxes. Now, there are certain things in our tax system that are refundable credits. Don't worry about those here. That's more complex we need to get here. So at least you pay nothing, right? Right? You're not getting any money back essentially here. Okay. So stop at zero. So make sure your calculations don't say you get paid money. Right. Right. Any questions, thoughts, concerns? Right. We got 2 weeks to work on this one. Again, if you want to get started in the loops early, they're not hard, I promise. But we'll cover that next week. Have a good MLK day, and I'll see you Wednesday.